Welcome back to The Explainer. Today, we're doing something a little different. We are going to deconstruct one of the most in-demand skills in all of tech by looking at the actual master plan, a real university syllabus for becoming a cloud expert.
So, have you ever stopped and wondered, how do you really become a cloud architect? You know, the people who build and manage the entire digital world we live on? Well, I can tell you, it's not some kind of magic. It's a structured path, a very deliberate process of learning.
And to show you that path, we got our hands on the curriculum for a university course called Cloud Infrastructure and Services. And together, we're going to pull it apart piece by piece to see exactly how you build an expert from the ground up.
Okay, let's dive right in. The best way to think about this is like building a giant skyscraper. Before you ever break ground, you need a blueprint, right? You have to know what the final building is supposed to look like and what it's supposed to do. That's exactly what this first part of the course is all about.
And when you look at these core objectives, it's super clear what that end goal is. This isn't just about memorizing facts and acronyms. Nope. The whole point is to gain the actual skills to design, manage, and optimize real-world systems. It's about becoming an architect, not just knowing the list of parts.
So, you've got the blueprint. What's next? Well, now you have to lay the foundation. This is the absolute bedrock. These are the non-negotiable concepts that everything else, and I mean everything, is built on top of. If you get this part wrong, the whole skyscraper is unstable.
And that foundation starts right here with the basic service models. You have to understand the difference between IaaS, PaaS, and SaaS. It really all boils down to one question. What are you responsible for? And what is the cloud provider handling for you? Are you renting raw servers, a ready-made development platform, or just a finished app?
And then you have to decide where this infrastructure is going to live. Is it going to be on a massive public cloud like AWS or Google? Or a private cloud tucked away inside a company's own data center? Or maybe you need a strategic mix of both, a hybrid model. Any solid curriculum is going to cover all three right at the beginning.
All right, foundation's poured. Now it's time to start putting up the steel beams. We're moving up from the bedrock to the core engine of the cloud. This is the technology that actually makes the whole thing possible. It's the secret sauce that lets one massive data center serve thousands of different customers all at once.
And that secret sauce has a name: virtualization. At its heart, it's a brilliant trick. It's all about using software to make one powerful physical computer act like it's many, many smaller, independent computers. This is the concept that unlocks the immense scale and efficiency of the cloud.
Now, this brings us to a huge debate in modern tech. Do you use heavyweight virtual machines or lightweight containers? A VM is like giving each tenant their own heavily isolated concrete-walled floor. A container is more like a nimble, fast, prefabricated office pod. The syllabus dives deep into this because knowing when to use which is an absolutely crucial skill.
And we're not just talking theory here. The course gets you hands-on with the titans of the industry. From hypervisors like VMware that create the VMs, to Docker, which packages apps neatly into containers, and then the big one, Kubernetes. Think of Kubernetes as the master site foreman, orchestrating thousands of those containers at massive scale.
Okay, the skyscraper's main structure is up, but it's useless without plumbing, power, and security systems, right? In the cloud, that means networking and access control. You have to connect all your resources together while protecting them from the outside world.
The syllabus shows you exactly how to build your own private, isolated section of the cloud, step by step. It's just like building out the secure floors and hallways of our skyscraper. You define your public and private areas with subnets, create the hallways with routing tables, and basically put digital firewalls on every door with security groups.
So once the structure is built and the doors are in place, you have to control who gets the keys. That's where Identity and Access Management, or IAM, comes in. You can think of it as the digital head of security for your entire cloud environment.
And this is way more than just passwords. This is a deep dive into the policies that secure massive companies. It covers things like authenticating users to prove they are who they say they are, and then authorizing them, which decides what they're actually allowed to do. It's all about giving people the exact permissions they need and nothing more.
Okay, so we've covered a lot of theory. The blueprint, the foundation, the structure, the security. But theory only gets you so far. This last part of the journey is all about tangible proof, proving that your skyscraper is fully functional. This is where learning gets real.
And honestly, this is the wow moment. This isn't just theory. The syllabus is packed with hands-on labs for both AWS and Azure. Students aren't just reading about load balancers, they're configuring them. They're not just learning about serverless, they are building real automated workflows with tools like AWS Lambda. This practical, hands-on experience is what really transforms a student into an architect.
So when you deconstruct it like this, you're not just looking at a course syllabus. You're looking at the blueprint for today's cloud expert. But that leads to a bigger question, doesn't it? If this is today's blueprint, what will tomorrow's look like? The foundations, networking, security, virtualization, those will probably remain. But the tools and techniques, they will constantly evolve. Which means maybe the real skill isn't learning how to build today's skyscraper, but learning how to learn.